All right, lesson 7. I'm going to talk to you today about the unit circle, which is just another tool that we use to help us find the sine and cosine of angles without needing a calculator. So let me just give you the quick background on the unit circle. This isn't anything that you need to specifically know. I just want to show you where it comes from. So what is the unit circle? A unit circle is a circle whose center is at 0, 0, which we know as the origin, and it has a radius of 1 unit. So that's why we call it the unit circle. Its radius is 1 unit, and that unit could be meters, could be inches, could be feet, could be whatever. All right, so this is the diagram of the unit circle. Now, the other thing that we're going to start talking about and use is this symbol right here, which is the Greek letter theta. Now, you've seen that before in geometry. You learned a formula in geometry, theta equals S over R, which we're going to revisit here soon. But for now, I just want to introduce that Greek letter to you. When we do algebra, we use X most of the time when we solve stuff. In trigonometry, we use theta instead a lot. So it doesn't always have to be used, but it's used a lot in trigonometry. So that's what you're going to start seeing. So let me show you how this unit circle works. So I have a line extended out here. I have this angle drawn right here, and I'm going to call it theta. Put a little theta in the corner right there. So this angle has opened up and landed right here. This point right here where it's crossed the outside of this circle, I'm just going to label it x comma y. It's some random coordinate. I don't know what the coordinates of that exact point are. I just know that I had to go over some distance x and up some distance y to get there. And I've created a right triangle by doing that. So I have a right triangle, a theta in the corner, and because I have a right triangle, I can apply all of my rules of SOHCAHTOA. And in particular today, we are going to stay away from the TOA part. We'll get to tangent with all this in a little bit, not today. So let's just look at the SO part of SOHCAHTOA. If I wanted to find the sine of this angle theta that I have, I'm going to redraw theta here. It wasn't looking too good. There we go. If I wanted to find the sine of theta in this diagram, I'll just remember that sine is opposite over hypotenuse in SOHCAHTOA. So if I go to this angle theta that I have drawn here, opposite is y. The hypotenuse is 1, so I get y over 1, which is really just y. So that's telling me that sine of this angle is equivalent to the y value of that coordinate. Hold that thought. Let's do cosine real quick. So if I want to do the cosine of theta, cosine is adjacent over hypotenuse. Adjacent to theta is x. The hypotenuse is 1, so I get x over 1, which is x. So that's telling me that the cosine of theta is equivalent to my x value. So what this has all showed me real quick, and like I said, this is not a diagram that you have to memorize or anything like that. Just showing you the theory behind all of it, that when you are on the unit circle, a circle whose radius is 1, your sine value is your y value. Your cosine value is your x value. That is huge, and we're going to use that right now to find the value of sine and cosine of angles that are on this unit circle. So let me show you that now. So I'm going to redraw the unit circle. Again, unit circle is a circle whose center is at 0, 0 and whose radius is 1. And this time I'm going to put the angles in here. We have 0 here, we have 90 here, we have 180 here, and 270 down here. Remember, this is also 360 as well, or the same. So now that I have these angles drawn in, and I'm going to state that this is a unit circle, which means it has a radius of 1, I can name the coordinates of these 4 points that are on the unit circle. So if the radius is 1, that means this distance from here over is 1. So that means this coordinate right here must be 1, 0. Up here, this coordinate, since again the radius is 1, this must be 0, 1. This one over here, since we're going this way, is negative 1, 0. And this one down here would be 0, negative 1. So I now have the coordinates labeled for each of these angles. And I've got these coordinates because I know that this circle has a radius of 1. So what does that now do for me? Well, remember we just stated a second ago that when you are on the unit circle, your sine value is y and your cosine value is x. So if I wanted to know the sine of 90 degrees, I would go to 90 degrees, which is right here, and since sine is your y value, I would look at the y coordinate at 90 degrees, which is a 1. So that means that the sine of 90 is 1. That's how I can use the unit circle to help me out. So let's try this again. What if I wanted the cosine of 180? All right, here's 180. Remember that cosine is your x value when you're on the unit circle. My x value is right here. It's negative 1. So negative 1 would be the cosine of 180. All right, let's do that again. Let's do the sine of 270. 270 is down here. Sine is always the y value. So I go to the y value at 270, and it's right here. It's going to be negative 1 as well. Last one, I wanted the cosine of 0 degrees. So I go right here, 0 and 360 are the same. Cosine is my x value. My x value is right here, it's a 1, so the answer would be 1. Now notice I did not do anything with tangent in this problem at all, because tangent can be done with the unit circle, but there's more to the story. So we'll get to tangent eventually. For now, I just wanted to introduce you to the sine and cosine values on the unit circle. For those of you that took trig skills with me last semester, we did not do the unit circle this way. I'm doing a more simplified version of it just because of us not being in class together, not having the ability to answer as many questions as you would have in class. So I'm going to use this version of it. There's nothing wrong with it. It's just taught a little bit different. All right. Some things to remember, just so you can try to remember which one goes with which. Cosine comes before sine in the alphabet. C comes before S. So, and x comes before y. So that means that cosine goes with x and sine goes with y. That's one way to remember that they go together. Something you can utilize if you want. There's going to be some questions on the homework where you're asked to find the sines and cosines of these angles going around the unit circle. All right. Keep in mind that 270 is not just 270, for example. 270 is also negative 90 because they're coterminal. We learned that last week. So keep in mind that as you're doing questions that, for example, 90 right here is not just 90. 90 is also negative 270 if you went in the other direction. So there's a lot of ways I can use this unit circle to help me out. Say hello to all our Disney friends. Look, who do we got here? You guys know your Disney movies? We got Lady from Lady and the Tramp. We got Aladdin, or the Jasmine from Aladdin up here. Who else do I see? Let's see. We got Ariel from Little Mermaid, Donald Duck. This is great.